Hey everyone, Praveen this side. I hope you guys are doing great. So today we are going to solve the problem find H index, which is a medium level problem, and I personally like this problem very much because we have a lot to learn in this problem. Okay, so let's read the problem description first. The problem says given an integer array citations where citation of I is the number of citations a researcher received for the I at the paper. Now, what is citations? If we see the definition, in research terms, a citation is a way to acknowledge the original source of information, idea, or data used in a piece of writing by providing specific details about the publication so that the readers can easily find and access it. So, if you want to relate about what is citation, we have done mini projects and major projects, right? So, in our projects, whatever research we do, those are based on some research papers or some articles, right? So that is citation. That is, whenever we are doing our particular stuff, we are taking the reference of the original source of information and we acknowledge them, right? So that is citation. Okay. Now we understood about the citation, right? So let's get back to the problem description again. So we have been given an integer array citations where citations of I is the number of citation a researcher received for the I of the paper. So here index is acting as a paper and citations of I is the number of citations. That means the number of visits, the number of acknowledgements the researcher received. Okay. Now the task is to find the H index. Now we need to find the H index. But what is H index? H index is the largest value such that the researcher has at least H papers that have been cited at least H times. I know the definition is overwhelming, but it is very simple. So H index is the largest value such that the researcher has at least H papers. That is, whatever publication that the researcher has, it has at least H papers, and from that H papers, it have been cited at least H times. That is, that publication having at least H papers have to be cited at least H times, meaning it should be acknowledged at least H times. Okay. Now we understood somewhat about H index, right? But through examples, we'll understand the whole problem description clearly. So let's see the example 1. In example 1, the input is 30530 and the output is 3. The explanation says there are at least 3 papers 353 with at least 3 citations. That is 353. Let me mark it 353. Okay. So these 3 citation has 3 papers in it, right? So 3 has 3 papers, 5 has 3 papers, 3 has 3 papers, and they have cited 3 times. That is 1 time, 2 time, and 3 time. Now you must be thinking that I'm saying the same thing both for papers and citations, right? So this example is like this, but if we see the example 2, we'll get much more clarity. Now in the example 2, the citation array is 51241 and the output is 2. The explanation says there are at least 2 papers 524 with at least 2 citations. So the citations are 5 to 4, right? So how many papers these 3 citations have? These have 5, so we can consider 2 from it. This has 2, so we can also consider 2 from it. This has 4, so we can consider 2 from it. So these 3 citations have 2 papers, right? With 2 citations, with at least 2 citations. So how many times it has been cited? It has cited 1, 2, 3, right? So it has been cited 3 times, which is greater than 2. That's why here it says with at least 2 citations. Okay. Now this all underline has at least 2 papers, right? So 2 is our output. In our third example, the citations array has 0, 0. So there are no citations, right? So that's why the output is 0. Simple. So I hope we have understood the examples, not in detail, but at least the glance of it, right? Now let's take example 2 as reference and we'll try to find few observations from it. So what is our aim? We need to find the largest H index, right? Which has at least H papers in it and H citations in it, right? So here H index is not the index of array that we use. Instead, the element from the citations array. Okay, now we need to find the largest H index, right? So we'll be starting our execution from the largest element in this array. Okay, so what is the largest element in this array? It's 5, right? So we'll take 5 and how many pages it has. Since the element is 5, so the pages are 5 in it. Okay, So the pages are 5. Now, do we have any other citations with 5 pages? No, right? So here the citation will be just 1. So the citation will be 1. Okay. But these two are not matching, right? Although the pages are 5, but the citation is only 1. But according to the problem, we have at least H papers and H citations, right? So this will be discarded. Now, for 5, it is not there. 5 is not the largest H index, right? So what can we do? We can look for the immediate precedor of 5. What is the immediate precedor of 5? 4, right? So we'll check for 4. Now, for 4, we need to look for 4 pages. Now, how many pages has 4 citations? 5 has 4 pages and 4 itself has 4 pages, right? So we have citations 2 here. Okay. But again, for 4, both pages and citations are not matching. So what we'll do? We'll decrement the value again. So we'll look for 3. Now for 3, how many pages we want to look for? We want to look for 3 pages, right? So how many citations has at least 3 pages? Only 1 and 2. The same. So the citation is 2 again, right? So we'll decrement the value again. So we'll look for 2. Now we need to check for 2 pages. We'll check how many citations has 2 pages. Here for 5, it has 5 pages, right? So it can satisfy this condition. Here it is exactly 2. So it will satisfy the condition. Here the pages are 4. So it will also satisfy the condition. So how many elements we found? We found 1, 2 and 3, which is nothing but the citations, right? So we found 3 citations. Now whether this entry satisfies the condition, it has 2 pages, right? So H value is 2 and it has 3 citations which is greater than 2, right? So it satisfies the conditions. So 2 is the largest H index for the citation array. And if we check the example, here the output is 2. Simple. So this way we can solve our problem. Now let's take the quick recap what we have done. So we have started with the maximum citation from the whole citations, right? So 5 was the maximum citation. And how many pages it has? It has 5 pages, right? So 5 is the maximum element and we had found only one citation which was not satisfying the condition. So we gradually decreased the citation and the entry we found the both pages and citations entry were matching. That means both having at least H pages and H citations, then we consider that element as maximum largest H index, right? So the execution is simple, right? So let's see the code for it. Here's the code in C++, although the logic is same irrespective of programming languages. Okay, so the function name is hIndex and we have been provided the citations array. So firstly, I've taken the citations array size and stored it in n. Okay, then I have looked for the maximum citation. This is an inbuilt function in C++ which gives the maximum element from the citations array. Okay, so I have taken the maximum element and stored in max citation array. Okay, so after finding the maximum citation, I am running a loop till my maximum citation is greater than 0, and in each iteration, I am decrementing my maximum citation. How we did here? First we have taken 5, then 4, then 3, then 2, so on, right? Till it's greater than 0. So inside what I am doing? So I have declared the variable count here, and inside the citation array, I am checking whether the citation is greater than maximum citation, which is nothing but what we were doing manually. For pages 5, we were checking how many citations were having the pages 5, right? And whatever citation is greater than or equals to maximum citation, at that moment, I am incrementing the count by 1. Simple. After getting the count, I am checking whether the count is greater than maximum citation. That is, we have found here, right? The count was 3 here and the maximum citation was 2, right? So this condition was satisfied. So I am breaking from the loop. But if it is not the case, as we earlier discussed, we'll decrement our max citation by 1. So after executing this whole loop, either this max citation will become 0 or this condition is satisfied, right? So whatever max citation value is, we can simply return it, right? Here we have seen 2 was the maximum citation at which we found the condition. So this is the simple code, right? Now, what will be the time complexity for this approach? Here we are running 2 loops, one for maximum citation where maximum element is calculated, and if we check the problem here, the maximum element of the citation can be till 10 to the power of 6 here, right? So this can, in the worst case scenario, will be running for 10 to the power of 6 times, okay, which we'll consider as n, okay. So O of n, and inside we are again iterating in the whole citations array, which can also have the size of 10 to the power of 6, right, this one. So both has 10 to the power of 6. So the overall time complexity will be O of n square. And what will be the space complexity? Here, apart from variables, we have not taken any additional data structure. So the space complexity will be O of 1. Simple. Now, if you try to submit this problem, it will give time limit exceed, because for both n constraint, it is 10 to the power of 6. So 10 to the power of 6 into 10 to the power of 6 will be 10 to the power of 12, which will definitely give TLE. Okay. So how can we optimize it? Let's see that. So here I have taken the same array, and whatever table we have executed, I have taken the same. So during our dry run, what was going wrong? If we check again, we have started with element 5. So we were searching for 5 pages, right? And we found the citation to be 1. Okay, this is good. Now, when checking for 4, we wanted 4 pages, right? So what we did, for checking 4 pages, we have again iterated the whole array, and we found that 5 and 4 were the two entries. So the citation is 2. But do you think there is a problem here? No. We since know that 5 has already satisfied the condition. 5 already has 5 pages. So we have counted in this entry 5 one time, right? But again, when checking for 4, we are again checking for 5, which is wrong, because 5 has 5 pages. So won't it satisfy the condition for 4 pages? It will satisfy. So if it satisfy, why are we counting 5 again? If we take the entry of 2 pages, here we need to look for 2 pages, right? So while looking for 2 pages, what did we do? We check for 5, we check for 2, we check for 4. Okay, so checking for 2 is valid as it's a new entry, but the pages we are looking for is 2. So 5 and 4 we have already processed it. So does it make any sense to check it once again? No, right? Because if it has 5 pages, it will definitely have 2 pages also. So why to check 5 and 4 again and again? Are you getting what I'm trying to say? So the main problem is this loop that we were executing here. So for the count, we were again checking in the whole array whether that citation is greater than maximum citation, right? Although in the previous entries, it has 5 pages, it has 4 pages, but again, for the entry 2, we are again checking for 5 and 4, which doesn't make any sense, right? Now, what is the solution for it? As we are traversing in decrement order, that is, we have started with 5, 4, 3, 2. Doesn't it follow a sequence? It does follow the sequence, right? So we'll create an array of the same size, and in every iteration, whenever we encounter that element will be acting as an index for the other array that we will store, the frequency basically, right? And we'll increment its frequency so that we should never visit it again. So if I draw the array looks something like this here, where we have 0, 1, 2, 3, 4. Okay. So this array is same as the size of this array, right? So now we can increase the count of 2. So we'll increment this 2 value with 1. Simple. And for this, we can go at this 1 index and increment its counter. For 4, we can go at 4 index and increment its counter. When we make an entry at the maximum element, right, we'll never visit this entry, because when we go at 3 that we were doing here, we'll check at this index directly, that what is the previous values count that we have calculated here, so that we will avoid the execution of whole array. So it is simple, right? But if you look carefully, we are missing an element, 5, right? We don't have any 5 index here. So what can we do? Create an extra entry, 5, okay? 5, and we can store its frequency here, right? Suppose instead of 5, we have an element 6, 7 here, right? What can we do? At the 5 index only, we can directly increment the count. Okay, because we have created the copy of the same array size still here, but whatever element is exceeding this array size, we can directly store it in the next index, right? Be it 6, 7, 8, 9, 10. Okay, because we need to find the at least count, right? We need to find the at least count. And so now we'll map this value in this frequency array, right? Where if it follows under the range 0 to 4, which is the size of array, will increment in this only. But if the size exceeds the size of array, the extra entry box that we have created will increment its count here. Why? Because if the value is 1000 here, it doesn't make sense, right, to make the array size as 1000. The extra box that we have created, it will act the same. Okay. So here the value is 5. So we'll increment its count by 1. And the heads up is that we initially have all zeros in that. Okay. So that's why we are incrementing it by 1. Okay. Now for element 1, we'll increment its count by 1. Now for 2, 1. Now for 4, 1. And for 1, it will become 1 plus 1, which is nothing but 2. Okay. So it will become 2. So this is our frequency array, and at whatever places we don't have any value, we can assume them as to be 0. Simple. Now these indexes will be acting as the pages, and the element inside the array will be acting as the citations. Okay, if you see properly, for 5 we have 1, which makes sense. For 4 we have 2. So till here we have 2. So what can we do? Whatever citation for this index it has, right, we can accumulate it with the beside index element. Okay. Now for the index 2, which is nothing but the page 2, what is the citation? If you accumulate it from here, right, it is 3. So whatever citation we got, it's 3. Correct, right? If we again accumulate from this index till this index, it will again take O of n time, right? So whatever we done will become waste. So instead of that, we'll create a count variable, which will be initially 0. Okay. So we'll start from index 5. So what is the citation at index 5? It's 1. So we'll increment its count by 1. Now what we need to find? We need to find the citation which is greater than or equals to the page, right? But here the count is 1 and the page is 5. So this entry is invalid. Okay. So we'll go to index number 4. Okay. So index 5 is executed. Now we are going to index number 4. Now at the index number 4, the citation is 1. But we have already computed the citation as 1 here, right? That is the count. So we'll add this count to this. So it will become 2. Now whether 2 is greater than or equals to 4? No, right? So we'll again skip this. So we'll go to index number 3. Now the index number 3, the value is 0. So the count remains same. So whether 2 is greater than 3? No, right? So at index number 2, we have one citation. And if we add this, here it will become 3, right? 1 plus 2 will become 3. Now here our citation is greater than or equals to the pages we have. The same entry that we have found here, right? The pages is 2 and the citation is 3. So at this moment only, as our count is greater than or equals to pages, which is nothing but our citation is greater than or equals to the pages, right? So we can return its index as the largest H index. Simple. So by using our frequency array, we have smartly skipped this loop execution again and again, right? So I have just refactored our code solving the pain point. Okay. So let's see the code. So again the code in C++, but the logic remains same. Okay. So till here I have taken the citation size. Okay. But here I have taken the frequency array of size n plus 1. You know, right, why we have taken n plus 1? Because any element greater than n, which falls out of the index range, right, we need to handle them at the plus 1 position. Okay. So inside we are running a for loop where we are creating our frequency array. If that element is greater than or equals to n, I am incrementing the nth position, which is the n plus 1th position, okay, by 1. But if it is not the case, I am considering that element as an index for the frequency array and I am incrementing its count by 1. Simple. And remember, initially, as I said, all the entries will be 0. Okay. So after our frequency array gets executed, I have created a count variable and I'm starting from the last index. That's how we have seen in the execution. There, I'm running a while loop till our I is greater than 0. Okay. I'm adding the frequency of I in the count. I'm checking whether our count is greater than or equals to I. If it is the case, I'm breaking the loop. Else, I'm decrementing my I position. So this while loop will stop executing if I is less than or equals to 0, or we have matched this condition and break the loop. Okay. So whatever index we are at, I'm simply returning that index. Simple, right? So what will be the time complexity for this approach? Here we are running a loop of size n, right? So it will be O of n, and here we are again running a loop of size n plus 1, which can be approximated as O of n, right? So the overall time complexity will be O of n. Simple. And what will be the space complexity? Here we have taken a frequency array of size n plus 1, right? Again, which can be considered as O of n. And apart from this frequency array, we have just used variables, right? So the space complexity will be O of 1. So we have boiled down our time complexity from O of n squared till O of n, which is a huge optimization, right? And it was purely based on observation. So it all started from the brute force approach and till the optimization point, right? So I hope you guys like this video. If you guys really did, then please like, share and subscribe to my channel. It will really motivate me to bring more such content. If you have any queries or doubts regarding the explanation, please comment it down. I'll try to respond to it as quickly as possible. If you have any suggestion for my teaching, please comment it down too so that I can improve on that and deliver more better content. So see you guys tomorrow solving any other kind of problem. Till then, stay safe, stay happy and peace.